Ah, yes, banks. If you have a lot of money, it's one place where you do not want to put all of your funds into. So, of course, you'd rather invest it in a better place. But that's, of course, after you graduate, when you rake in a lot of money in industry, of course, you want to consider somewhere else to put your money. So, anyway, welcome to CS302 assignment 6. And for this assignment, looking at this character from South Park, this is what probably happened. I think Bank of America had this issue happen, I think around 2008 or 9 during that Great Recession. But anyway, we're going to just sort of use a hash map to implement this sort of bank type of database type system. And of course, a hash map is a pretty nice and fast data structure. And if we have a lot of records in the bank, of course, it beats doing a very slow linear search. So what we're going to have to do for this program is we're going to create our own custom sort of map or hash map class, if you will. And then we're going to, of course, have a main that uses our hash map to implement this searching or this program that's going to allow us to search for a bank record, an account, sorry, and then be able to deposit, withdraw, display everything, and so forth. So let's go ahead and first discuss the hash map class, and then of course we'll go into the actual main algorithm. Okay, so this video shouldn't be too long because really there's not much to say. I think a lot of the material is already in the PDF. So really I'll just sort of go over some of the details or some things you might miss or you might stumble across as working on the assignment. So this HashMap class, of course, is going to be, we're going to have this template. We're going to have our T1, T2. Remember, T1 will be our key type and T2 will be our value type. And for the most part, T1 will be a string type because, of course, it makes it a bit more interesting to use strings with our hash maps. And of course, I have written all of the contents out here. So I'm going to go ahead and just sort of discuss it in my own words first. So in our program, we're going to have two tables, table 1, table 2. And it's not going to be any array of linked lists. That's some good news. But of course, even if we did have that, I would allow us to use the standard list class, which is part of the standard template library, along with vectors. So really, having a linked list won't be so bad for this program. But I figured I'll just have a different implementation. So this will have two tables. So it's going to be a different version of sort of linear probing, or it's going to be a double hashing approach using two tables, and I have the description as to how you want to map things and how to handle collisions and so forth. But we're going to have these two tables, and we have a key value pair for each element. And of course, I actually gave you guys this constructor because this could be relatively useful, because when you allocate the space by using resize on table 1 and table 2, it's going to assign a default key value into every element of table 1 and table 2. So this is going to ensure that each element in your table is going to be empty, or it's going to be some default value. So let's say if your key type is a string, then every element in key will be some default variable or default string, or an empty string, if you will. And of course, if the value is integer, it'll be some default value. If the value is something else, it'll be some default value of that type. So anyway, that's going to be their two tables. Now, our hash functions, we're going to just assume for now that we're going to be using string variables as our key types. Now, of course, if you want to be able to handle more types, you'd have to actually either overload this hash function, or we have to pass in a separate class and then implement a hash function elsewhere. But I'd rather not get into that complicated stuff. So just to make things simple, the key type will be a string. So of course you can just use these two hash functions. And these are pretty simple. So here they're both defined. So of course for the first hash function, all you have to do is traverse each element of this string. So each element is going to be a character. So you want to get the ASCII character at index 0 of our string and then multiply it by 10 to the power 0, because I will be 0 initially. So it's going to be just the first character, the rightmost character of the string, multiply it by 1. And then of course, then you're going to take the next character in the string, multiply it by 10, and add that to the previous result. So this will be a summation, of course. Then I becomes 2, add that second character, multiply by 10 to the power 2 by 100, and of course, just applying this summation. Pretty simple. The other hash function we're going to have, well, it's going to be relatively also not so complicated, except it's going to be in reverse. So you're going to take the leftmost character in your string, and you're going to multiply that by 1. And then the character to the right of that, multiply that by 10, and so forth. And of course, you add those all up and return that sum. So really not a very complicated hash function. Relatively a good hash function for strings. So, again, you can see here that's going to be pretty fast because no matter how big the tables are or how many elements we have in our table, this function does involve a loop, but it's not going to scale to the size of the input. So really, if we had 1 million accounts in our bank, this loop is not going to take 1 million steps or any factor of 1 million. It's going to be unrelated to the input size. So you can see it's a pretty fast hash function. Okay. And of course, our items 1, items 2 is going to track how many elements we have in our table 1, table 2 respectively. So we're going to use this for our load factor amount. Then of course, we're going to have our resize function, which I'll talk about in a little more detail in a bit. So I definitely, I covered the private members, so that's all good. And of course, you can read through the PDF on that later on. Let's first go over this constructor. So we're going to assign some default value of 5. So this constructor is going to take this size parameter. Let's see if I can find the constructor right here. There it is. You're going to essentially just, you're going to say table1.resize with that size parameter and table2.resize that size parameter. So of course, he's going to just create 2 tables of both length size. Now, if you don't pass anything to the constructor, then 5 by default will be assigned to that size parameter, to this size parameter right here. So in your program, do not use a different amount for your size. And do not, do not internally assign the tables to bigger amounts because we want you to test out your resize functions. Because at some point, your table will get, load factor will get pretty large. And of course, you want to resize to avoid having a full table. Remember, having a low load factor is going to really give us a very good probability of having a fast runtime or expected runtime of constant for our insertions and searching. So do not mess with the parameter size, use 5, and then assign 5 to table 1 and table 2's resize amounts. So the 2 more complicated functions will be the operator bracket and the resize function. So operator bracket, well, it's essentially right here. Of course, you can follow it kind of step by step. So you first check for load factor. If it's 20% or higher, you're going to call the resize function. You're going to pass in table.size. So the resize function, you're going to pass in an amount you want to resize the tables by. So for example, if your table size is 5, then table1.size passes in 5, so it's going to double the table size. If table size is 10 currently, and you pass in table1.size, so you pass in 10 into the resize function, then again, you're going to double the table size. So essentially, this doubles the table size, pretty much. And okay, first take care of it if you have a high load factor. So if either table 1 or table 2 has 20% or higher, resize. After that, you're going to go ahead and compute the 2 hash values, modify table size to make sure this value does stay within the bounds of your table. And then what you're going to do is you're going to essentially create 2 collision counters, I1 and I2, and you're going to run this algorithm. So essentially all we're going to do is first check table 1. If table 1 is blank, of course you're going to create the entry in that spot by, of course, remember you want to do table 1 bracket index 1 dot key equals this parameter key. So you assign that key to that location. So of course you'll be able to find this element in the future, of course, right? Then increment this items 1 by 1 and then return table 1 index 1 dot value. Now, of course, if let's say table 1 index 1 dot key matches that parameter key, then simply just return table 1 index1.value, return that value field automatically. And of course, in that case, you don't have to increment items 1 at all because you located an existing entry in your table. You did not create a new entry. Now, if you have a collision at table 1, so let's say table 1 at index 1 is not blank and is not a match either, then next step, do the same exact thing, but for table 2. Same word. So at table 2 and index 2, apply the same technique. So you check the key, make sure if it's empty, that means create the entry. If it's not empty, if it's not blank, of course, then check if the key matches. Now, of course, if table 2 or table 1 index 2 dot key equals, well, if it equals this amount right here, if it equals T1 parentheses, that means that entry is blank. That's how you can tell if it's a blank entry or not. So anyway. So again, you check for table 2. And of course, either you return that value if you find a match, or if let's say it's a blank, you assign that key to that parameter key. And then you increment items 2 by 1 because the second table, you inserted a new element into that table and return a value field. Now, if you have a collision at both spots in your table, then of course you're going to reassign index 1, index 2 accordingly. So of course, on an even iteration, you're going to use the hash function 2, multiply it to the collision counter, add that to index 1, and modify table 1 size. Now on odd iterations, you're going to use hash 1. So just a little bit, we're going to sort of flip-flop. We're going to alternate between these. So on every iteration, so when you're going from step 4, 5, and 6, that's going to be one iteration. That's one iteration of this loop. So you can see here, steps 4, 5, and 6 is definitely looping. Right here, you can see at the end, you go back to step 4. So this is a loop right here. So that's still after one iteration, you want to alternate these. So at first iteration, you would probably do this. And index 2, same thing. You have the collision counter 2. Multiplied by hash 1 key, modified by table size. Next iteration, you just alternate. So these just alternate. So first time you do this, and then this. Next time around, you would do this, and so forth. That's about it, really. So not too bad, I don't think, at least for this hash bracket operator. So this bracket operator will serve as insertion and find. Now, the last thing I'm going to do for the resize function is that, let's talk about resize function for a second. So for the resize function, what you're going to have to do, so let me just scroll up here for a second. Here it is. Now, I don't have a lot written down here for the resize function, but what you're going to have to do to implement this is, well, I would say you can, of course, use the bracket operator in this function body. So using the star this object, you can call star this object's bracket operator. So you can call your own bracket operator within your own resize function. So what you would have to do is you can, of course, create two temporary vector objects and just copy table 1 and table 2 into these two vector objects. And since they're vectors, you can easily use the constructor for the vector class or the assignment operator to copy from table 1 and table 2 into these two temporary objects. And then, of course, you have to clear out table 1 and table 2, and then resize it to a bigger amount. And then, of course, you can traverse those original those temporary two vectors, traverse every spot that's not blank, and then just use the star this bracket operator, and then insert that key into this larger table. So essentially, you create two temporary tables, resize table 1, table. Well, first clear out table 1, table 2, resize them, and of course, just traverse those copy tables. Just traverse every element, and for each element that's not blank, use star this bracket operator to map it to table. Or you can, of course, copy and paste the entire bracket operator function. Either one is okay. So this might cause some issues for you. So what I would suggest is, for now in your program, you can just create your table size to be a very arbitrarily big size, so it will never have to resize, just so you can test to make sure that your bracket operator is working. Of course, later on, you can, of course, update your initial size of your table 1 and table 2, and then of course you can be forced to use the hashMap resize function. Okay, so that sort of summarizes up the entire class hashMap. Let's now talk about the actual main algorithm and also the input file you're going to have to work with. Okay, so before I go over the actual main algorithm, which of course you can read in the PDF yourself, I want to just go over the input file given to you. So you're not going to have to actually read the input file name from the user. You can create an input file stream variable and hard code the file to just be data.csv. So I'm going to have you guys read a spreadsheet file. So you might have encountered this in CS135. If you have not, of course, I'll talk a little bit about that as well right here today, or in this video, sorry. So pretty much here's your files. I'm going to go ahead and I'll expand these a little bit so you can see what's going on. Okay. So you can see here this first line in this spreadsheet file or a CSV file is simply only just giving that heading. So first name, last name. So this whole column here is going to be first name, last names of people, location of the branch of the bank branch, and of course here's the account number, the current balance, and their PIN. So if you haven't done CSV files before, it's nothing to be too terrified about. This looks really scary, but let's go ahead and open this up in a different format for a second. I'm going to right click, edit with Notepad++. So if you can see this, it's really just a regular file, except that it's comma separated. So CSV stands for that, or comma separated, but I don't know what the V part stands for. So comma separated something, but it's a comma separated file is the idea. So you have the first line contains first name, comma last name, comma location, comma account no, comma balance, comma PIN, and of course every line is ended with a Linux style end of a line. Ooh, shows Windows here. It's weird. That's odd because it works on Linux, so must be just kind of coincidence, I guess. But anyway, it's supposed to be Linux formatted, but anyway, it's Windows for some reason. I don't know why that happened. Anyway, didn't cause any issues when I ran my program, so it shouldn't be an issue for anybody else either. So for this second line, we have EDET, Deleuze, Spring Mountain, account number matches. So really just the first column is just this string, and these commas separate these columns. You're probably wondering, why am I using this comma separated file? Why not just use a regular txt file and space separate? And the reason why is because some of these, so for example, Spring Mountain, we have Spring space Mountain. So if it was not comma separated, how can we tell that Spring Mountain should be one attribute, not two separate attributes? And also, now you could say, well, can't you just merge them into one word? And I guess you could, but I create this input file using, I think it's Macaru, some kind of a data set creation file. And it randomly creates these first and last names. And sometimes the last names, I can't guarantee that the last names aren't going to just have like one of those kind of double last names. Like I had a friend when I was in grade school called Jeffrey Saint Jean. So Saint space Jean was all one last name. So some of these could have those type of names, and it's kind of hard to tell which ones. So just to be safe, a comma separated file will definitely handle that ambiguity. But anyway, in the actual file I provide, I gave you guys a sort of in the PDF, I sort of go over how you can parse this CSV file. So again, 135, you learned this, but if you haven't, it's okay because we can cover it right here actually. Let me see, I think I have the input somewhere over here. There we are. So here I showed you, so if you have a single line like this, of course, you have to do a get line. and then in file, comma, line to line contains the entire string. Okay. Now using the substring and finds, check this out. If I say line.substring from index 0 in the length, I pass in line.find. Line.find returns the index of where the comma was found. So it's going to essentially find a comma right here in that string. So it's going to return edet, and it's going to store this into a variable called string first name. And then I can remove this substring from line. So if I use this line of code, so line.erase 0, comma, line.find, comma, so it's going to find the location of its index of its comma, and then of course +1, because we also want to include the comma as well. This will remove everything from the string from index 0 up to the comma. So now, after I run this erase function, then only this part of my string will be present. It's going to not contain edet anymore. So if I go ahead and apply the same technique, line.substring 0, comma, line.find, comma, it'll find this is going to be your new index 0 from now on. So then comma's found right there. So it's going to return, it's going to extract the lose out of that string and store it into last name. And then so on and so forth. So you just kind of do this for each entity. And of course, some of these, I think the pin and the balance has to be stored as, well, the pin's as integer and balance is a double. So you have to use A to Y and S TOD to convert those strings to ints and doubles. Again, that shouldn't be anything too bad. So just don't use string stream for this because I guess it's always kind of frowned upon because string stream is a very weird library. So of course, if you were doing this in Java or C#, there is a split function, also in Python, a split function, which you usually can separate. You can tokenize a string by commas, but C++, of course, doesn't have that. So using find and substring and erase is sort of at least we're using the string library functions to separate all this. But of course, you want to separate each entity one by one like that. And after that, once we're able to do that, we have to, of course, store this into our map. So let's go ahead and now go into how to actually, how to visualize our map, or at least I can kind of give you sort of a nice picture of it in a sense and go over the map actual structure. Let's get to it. Okay, so before I go into the actual map structure, I do want to actually talk a little bit about this bank type struct you're going to have to work with. So you can see here, you're going to have a two-dimensional map, which does seem a little bit scary, but it's not really as bad as it seems. But I'll cover that in a little bit. But I want to first talk about this struct bank type you're going to want to include in your main file. So we have this nested struct structure, but I'll go over what this transaction type will be in a second. But for every bank account, a bank type will have a name associated with it, account number as a string, a balance, PIN, and of course if the account is locked or unlocked. And then we also have these constructors. So I have this first constructor right there, which just will make your life a little bit easier. So you of course I'm going to probably even give you a provided main with just this stuff declared, so you don't have to actually worry about this. But this is going to allow you to make it much more easier to initialize new bank records. So of course, this constructor will just set all these up. Default constructor right there, which this actually can be used because since we don't have a find function in our hashMap, whenever we look up an account, if it returns a blank bank type, then we can use that as a way of sort of telling that we did not find, or this bank account record doesn't exist. So this can be used actually for a failed search. Anyway, now we have this transaction type defined within our bank type, and this is going to be used to sort of log all the transactions made on any account. So I think I have a typo. So let's be we have a list of transactions. So I'm going to fix that before I upload, or I'm probably going to forget to fix it before I upload, but just so you know, right now it's supposed to be list. I'll have a list of transactions anyway. So, okay, so basically we're going to have to store all the transactions. So whenever we deposit onto the account or whenever we withdraw from the account, you want to log all of those. And it's going to be some type of a centralized. It's not going to be a Bitcoin network. It's going to be not a blockchain, but it's going to be this centralized bank records, which is kind of the reason why that whole issue happened over a decade ago. Anyway, I'm sidetracking there. So we're going to have to, so every transaction will be either withdrawal or deposit. So if the type is true, then it's going to be a deposit, and false for withdrawal, or vice versa. And the amount will be how much was withdrawn or how much was deposited, basically. And of course, you have our constructor, which could be also makes it easier to set this up. So you can set a transaction a transaction for the account. So this vector that's going to be inside of the bank type, we have a vector of transaction types. So of course, we can, every time we withdraw or deposit from an account, we can just push back a transaction type to the back of this vector to simply just keep on, so we can keep on inserting transactions as needed. So whenever you make a transaction, withdraw or deposit, you're going to, of course, push back a transaction type. You pass in true or false, and then the amount the user wants to withdraw or deposit, and then it'll insert into this vector like that. So that's just the data we're going to be working with. Now, of course, now I want to go ahead and now draw out how we can visualize this hash map structure, this 2D hash map. Then, of course, I'll go over the main algorithm and also do a little test run here in this video as well. Okay, so here's going to be our bank map. So we have a 2D map. So we have a string. So for example, we can have this first string will be used as a location. So Durango will map to, I guess I use a small example, but will map to these 3 accounts. Fort Apache maps to these 2 accounts. The Warm Springs will match that 1 account right there. So the first, so this first sort of string right here, that's going to correlate to Durango, Fort Apache, Warm Springs. And of course, this string right here is going to correlate to those numbers, those last 4 digits of the account, essentially. Each of these will map to a bank type record. So the purpose of doing this is, for example, maybe some locations, this is not realistic, but I guess this could happen not in this situation, but it could happen in general, where what if we have the last 4 digits of one account, you know, be the same, but in 2 separate branches? Then, of course, it will not cause any, not duplicates, but it's not going to overwrite other records. Now, of course, for banks, a different branch has the same records, but for now, we'll assume that, you know, each bank will have their own set of accounts designated just to that bank branch. So having them in separate locations like this is the better way of going. So pretty much the way it's going to work is, let's say if I wanted to look up, I want to look up this record right here. Well, the way it would work in your program is just, you would just say your bank object, you pass in Durango, and you pass in 1, 2, 3, 4, and that's it. So this first level of indexing is going to access, is going to find a match to Durango. Is going to access this entire map, because bank Durango is going to be its own map of all these accounts associated to Durango. And of course, this second number right there is going to use this as a search value, and it's going to now retrieve this record. So now we're looking at that record. And of course, now we can do, you know, dot name to access that name field, or dot pin, dot transactions, and so forth. So that's all we have to do. And of course, you know, I can also use, you know, I can do, well, get the other account. I could say bank Durango, and then 3643 would access this account right here. So you go through the first level of indexing or searching. You first find that Durango map, then we find this record, is what we're doing. So really you have to go through 2 levels. So location, then the bank account. So of course you could have had a vector of maps instead. So of course you linear search it, but we don't want linear search. You want to be able to quickly in constant time look this up and in constant time look these up. So it will take just 2 extra steps, but it's still going to be constant runtime to find a particular bank object. Now, of course, the way this could also work is like this. So let's say, for example, if let's say I try to search something like this. Bank Durang, let's say I try 1111. Like that. Well, in this picture, clearly, this record doesn't exist. There is no last 4 digits. There is no search 111 in Durango. So this is going to actually create a blank entry. But you can check very easily if it's blank. I mean, the simplest way is what if, if I go ahead and say dot name, if it equals an empty string, that means this object was never set to anything. Now, of course, if you want to add a new record, let's say you read from an input file, you actually want to insert in Durango 1111, you of course can easily just bank Durango 1111 equals bank type, and you pass and all your stuff into this constructor, and it will assign that value field of this bank record that gets created on that spot if you were to actually add an element. But that's all there is to it, really. So it seems like a little complicated, but this is easy. I mean, you just simply just bank the location and then the actual account number, or we're going to store the last 4 digits of the account as our search key. And that's it. So hopefully this kind of clarifies, or at least somewhat makes it less scary looking. Now let's go ahead and talk about the main algorithm in the PDF next. Okay, so I guess all the steps are written right here, but I'll just sort of go ahead and just talk a little bit about this. So, I mean, this is going to be sort of a menu-driven loop, essentially. So you first ask the location for the user by asking them, you're going to prompt this to the screen, please enter bank branch location, you're going to read in a bank branch. Now, of course, in step 2, if this does not exist, so we have a set of locations. Let's say if you try, can't think of Las Vegas streets right now for some reason, but let's try, if you try Torrey Pines, for example, that's not going to be found. So you want to be able to figure out, well, how do I know that Torrey Pines is not in my list? So, I mean, a hint, you can use more than one hashMap if you want. Now you have to declare a 2D hashMap. You have to do that, but you can have additional hashmaps as needed. So just a hint, you can use that another hashMap maybe to find if this branch exists or not. Anyway, if it doesn't exist, go to step 14. So it's here. I'll get to that part. Step 14 is pretty much just, you simply prompt you that they want to continue or not. If they want to continue, go back to step 1, else end the program. So step 14 is just that final thing, just to do, just to ask them if they want to continue or not. Okay. Then of course, if the branch is found, ask for the account number, ask for the last 4 digits of the account number, and do a search on that. Now, if you can't find that account, output not found, go to step 14. Otherwise, go to the next step. Then you want to check in the next step. Okay, account was obviously found. If the account has a lock on it, so if the account's lock boolean contains true, then obviously it's locked. So go to step 14. At this stage, step 5, location was valid. The account number, the last 4 digits of the account is valid. Ask for a PIN. If the PIN matches, using, you can maybe store from step 1, you have a variable called location, and then step 3, you have a variable called ACCT for account. So of course, we use the 2D hash structure. If this pin field matches the pin read in step 5, then go to step 8. Otherwise, oh wait, my mistake. If the pin matches, if the pin matches, then go to step 8. Otherwise, you tell the user invalid pin. You maintain a counter. So after you output invalid pin, you jump back to step 5. And you keep doing this until either you get the right pin or after 3 failed attempts. So if you have 3 failed attempts, output the account is, 3 failed login attempts, the account is now locked, not the account is not locked. My mistake. It's supposed to be account is now locked. Or hopefully in my code I didn't misspell that too, but it's supposed to be account is now locked. And then go to step 14. It means that it was a failure. Step 14 is sort of the pit of misery, I guess, in a way. So let's say they finally get a valid pin. We jump to step 8. So now we have access to the account. So ask the user if they want to deposit, withdrawal, or view the account info. So for deposit, ask them for deposit amount. Add that to the balance. And of course, store that deposit amount into that account's transactions. If it's a withdrawal amount, of course, withdraw, subtract that amount from the balance. If it's possible, if not possible, then just do not subtract anything from the balance. If it's able to withdraw that amount, subtract it. And of course, store that into the transactions vector. If you entered V to view, just show the account name, the balance, and the list of transactions if there are any. If there's no list of transactions, just output no transactions. And then if you enter E, then that means you want to escape out of this account. Otherwise, if I say entered, that's not a valid option, go to step 8. So all of these except for E, they all result go to step 8, which means you're going to basically prompt for an option. So you keep on prompting the user to deposit, withdrawal, or view, or exit. You keep doing this menu until the user enters E to escape. And then step 14, ask to continue. If you want to continue, jump to step 1, else end the program. So that's pretty much it. Now, some specifications. You want to, of course, add header comments. You add your, the same comments you have to add for all of your class assignments to this point. And also do not use linear searching. Always use a hashMap for all your searches. Do not modify the initial size of your tables in your hashMap. Now, of course, you can for debugging purposes, but when you submit the assignment, make sure you don't do that because that will assume that you didn't get the resize to work, which means you have to take some points off of your assignment grade. Because of course you want to see if your resize is working. And of course, do not use unordered map in this assignment because that would defeat the purpose of the assignment slightly. Because although there's a lot of work to be done in main, you still have to create your own custom hash maps. So that was sort of one aspect of the assignment as well. Now, of course, you can use unordered map to test out your program, your main program, of course, but when you submit, please use hashMap, because again, if you don't use hashMap, I'm going to assume that there was some problem in your code. That's why you didn't want to submit that, which would probably result in a pretty big amount of points taken off. So there's that. I also have the example output provided in this PDF, but I'll just go ahead and I'll give you sort of a interactive output right here in this video. So let's go ahead and show that part next. Okay, so let's go ahead and compile the program. So of course, since it's a templated class, we're not going to actually link them separately. We're going to have one, we're going to sort of compile G++ main only. And of course, we included hashmap.h in the main file. There it goes. Okay, so obviously what happens is, again, you don't have to read in the actual file name. It's going to be hard-coded into the input file stream. And of course, we populated our map structures accordingly. So let's go ahead and sort of enter a location. So if I were to enter an invalid location, let's say if I typed in Torrey Pines, that's not in this list. Of course, bank branch not found. Of course, you want to, in constant time, know that. We don't want to actually do a linear search to see if torrey pines exist. And of course, then we have to, of course, go step 14 to the pit of misery. I'll enter Y to continue. Of course, it'll enter a bank branch location. So let me just look at my CSV file right here. And I'm going to just pick one of these. Let me see which one I wanted to use. Okay, this one. So I'm going to go ahead and type in Maryland for Maryland Parkway. And it found the location. It doesn't ask me for the last 4 digits of the account. So I'm going to first enter an invalid account. I don't think this account is in Maryland. And it says account not found. So back to the pit of misery. So I'm going to enter capital Y this time, and it will rerun. And I'm going to go ahead and now I'm going to type in Maryland in all capitals. You have to make sure your program is case insensitive. So of course you have to format your strings accordingly, which I don't think should be a big problem in CS302. Okay, so now the account we have, I believe, is 3665. So 3665 is a record. So you can see here, it found the record. So it asks for a PIN. So the PIN is 6608. And now it's giving me this option. So deposit, withdrawal, view account X. I'm going to type V to view. I want to view the account for right now. See if it does match. And I believe in my spreadsheet file, so on line 23 in my spreadsheet file, we have, looks like Godmar Vani, and that's going to be their current balance. Looks like it's all okay, and it shows no transactions. Okay, fine. Let's go ahead and actually deposit. So I'm going to type in a lowercase d. Deposit amount, I'll just deposit $500 and I guess I need 25 cents. Okay, cool. Let's go ahead and now, so we can see it loops to this menu again. So I'm going to type V to view. And the same person, we have a different balance, obviously. And we have a list of transactions. So we deposit amount this many. Let's go ahead and just withdraw something, I guess. I'll type in lowercase w. So again, it has to be case insensitive for this part. Enter withdrawal amount. So let's try 250.78. Let's go ahead and sort of type V enter. And we can see that we have, this is a current balance, and we have the deposit of this much, and we have a withdrawal of this much. And I guess I'll do another withdrawal again. 375.26. Enter V. And we can see this transactions vector in this object. We push back one, push back again, push back again. So we have these 3 elements stored in there. Now, of course, if I want to withdraw a really big amount, say I try W again, I'll try to withdraw 2,000, which I don't have the funds for that. It outputs not enough funds to make transaction. So I'm going to, of course, I'm just going to display it. And we can see here I did not push that transaction to my transactions list. So there we are. Now I'm going to hit escape, E to escape out of this account. Now we're back to the pit of misery. So I'm going to go ahead and enter, I guess, capital Y to restart this program again. And let's see. I'm going to now try, I guess I'm going to go ahead and try blue diamond, I suppose. So I'm going to type in blue diamond all in capitals. So blue diamond. So you want to be careful when you have to read in multiple lines like this. So typically you're used to using cin with the input operator, but you may want to do a get line here, but you may not want to, because if you do a cin with the input and get line together, you might have encountered this problem, but it will cause issues. So what I did actually is I would do a cin with the first string, red and blue, and I would do a peek. So look up how cin.peek works. I would peek the next character. If the next character is not end of line, I would cin again using a loop. And I would just sort of concatenate blue, space, diamond. And if I do a peek again, if I see an end of line character at the end, then I'm done. So just, you know, a little bit of advice right there for you. A little free advice. So blue diamond, let me see which one I'm looking at. Let's look at this account here. So you have 4524. So 4524. That's the account. Now I'll enter invalid pins. So I'm going to go ahead and enter, let's say 1111 invalid, 2355 invalid. And for the last attempt, I will be smart and put the right pin in. So 5, 6. Let me just make sure 8, 3. This is the line 20 record, and I found it. Let's enter B to make sure everything is correct. So I think that is the right person. Yep, that's the right name. No transactions made so far. So all good. So let's go ahead and now I'm going to just escape. I'm going to see what was the other record I had right here, Bonnie. Okay, I'm gonna go ahead and try this again. So Maryland or Maryland. So we have 3665. If I enter, let's say 3 failed pins, oops, that's not a correct number of digits even, but it's okay. That's invalid. And now the, yeah, there we go. See, at least in I have it as now locked. So it is correct in the actual code. It's misspelled in the PDF. That's probably the better of two worse situations. Oh geez, I actually misspelled the word account. Anyway, I'll have to probably fix that on the code grade as well. So I will have it fixed on code grade and the PDF, everything before I officially do this. So to make sure everything's okay. So I'm going to blame it on my keyboard because I've had moments where my keyboard, I click on some of the buttons, doesn't actually work. But I think only the J key is the only one that doesn't work. But it'll be our little secret. It's the C button that has the problem. It's not me because I can't spell correctly. So anyway, let's go ahead and try this again. So I'm going to now try the same. I'm going to go ahead and try the same person. So Maryland. And let's see. So Vonnie, it's going to be 3665. So 3665. And we see here that the account has a lock. So I spelled account correctly there. So at least I can spell it sometimes correctly. So we see it did find the account, but it has a lock. So then we're not going to let the person do anything with this account. So I'm going to go ahead. I'm going to end this now. So, and enter. And there we are. There's going to be our demonstration of this program. So of course, there's a few test cases in code grade. I have a test. It's also a set of, or sort of a test output run also in a PDF as well. But anyway, I hope this video did help you get a good idea of how this program works. So I guess happy coding and till next time.